All right, in today's pre-calc video, we're going to go over some examples of using the product property for logarithms. If you recall, the product property is that you can take the log of a product and you can pull that apart and turn it into the individual logs of a sum. So you can do, for instance, on this first example, we could take log of 11 times x times w, and notice that we have a product of 11 and x and w, log of 11 times x times w. And when I have a product like that, I can instead pull this apart into log of 11 plus log of x plus log of w. Sometimes this is also called expansion of a logarithm because you see that it's written down much longer than the original, but it's actually quite a bit simpler because log of 11 can be done on the calculator, and then we are down to just log of x and log of w as well. All right, let's look at another example. So in this example, it says rewrite the logarithmic expression as a single logarithm with the same base. Notice that all of these logs already have the same base. The base is 10 whenever the logarithm is not showing its base. That's called the common logarithm. But when you have the same base on all of your logs like this, you can use that product rule backwards, and you can, instead of expanding, you can pull these together into a single logarithm of the product. So you just have to imagine the reason that these three things are all being added together could be that it came from the log of 8 and the product of 4 and the product of 7. And this is, of course, the log of 224, which you could then check that all of this is true and making sure that all of this is working by putting the original into your calculator with base 10 and putting the ending in your calculator with base 10. And it would give you some extra evidence that the product rule for logarithms really does operate this way, and it operates correctly to get an equivalent result. Let's look at another example. So here we have E involved. Now E represents Euler's number, is roughly equivalent to 2.718. And it's the type of number that it's best to just write E instead of writing out a long string of decimal places. An infinite string of an irrational number is not really good to keep writing down. So we represent that with just the simple letter E, named after Euler. Now, when we're looking at this, again, we want to notice we have the same base. All of these logarithms are base 3. So we can just use our product rule again. We'll put all of these logarithms together. Our answer will be in base 3. And we'll have log base 3 of 4e times e times 3e. This, of course, simplifies to log base 3 of 12e cubed. Some people like to put a parentheses around the argument inside their logarithm just to keep everything straight. It can make it easier to understand you're doing log of that entire amount. All right, next example. So in this one, again, we'd like to pull this apart with our log base 9. So write your answer as a sum or difference of base 9 logarithms or multiples of base 9 logarithms. The inside of each logarithm must be a distinct constant or a variable. So let's expand this out and see what we've got. Log base 9 of w plus log base 9 of x plus log base 9 of v. So that certainly wasn't that bad. Next example. In the same way, any base, for instance, here we have log base w, you can still do this same rule. Log base w of u plus log base w of x plus log base w of v. And we've expanded out this logarithm as well. All right, in our last example, we've got a slightly different type of question. This one says prove this statement using properties of logarithms. So of course you could put these into a calculator that's capable of log base 7, but to use our property of logarithms, all we would need to do is take the logarithms over here on the left side and see that we could turn that into the log of a product. We would have log base 7 of 6 times 9 times 7. And the question is that the same as log base 7 of 105? Well, since 6 times 9 times 7 is 378, it seems to me that log base 7 of 378 is not going to be the same as log base 7 of 105. And I would say no, I cannot prove that to be true. If I were to get the same amount on both sides of this, along with having the same base, well then clearly those things would be equivalent, and I could prove that. So here is our product rule that we're going to be using in questions. It says that log, as long as these two logs have the same base and they're added together, I can combine them into a single log with that base where the expressions of x and y are multiplied together instead. Or I could do that the other way around. I could take a log with a specific base, multiplied things inside of the log, a product. And the reason it's called the product rule is I can then change that into an expanded thing with the same base with a plus. So you can either do this way or you can do it that way. Many different uses for your product rule for logarithms. Hopefully that helps. And there's a pretty quick, simple little way to remember this, is that when you see a product, you can change it into a plus. When you see a plus, you change it into a product. And that's how logarithms work. They both start with that letter P.